Okay, so in this experiment, what I'm going to do is I've got the cup on the floor. I'm going to fill it with hot water, and then I'm going to put an ice lolly into the hot water, and the results you might be able to predict. So here's George, just watching what I'm doing. Don't think he understands quite what I'm up to. Here's the hot water, just freshly boiled in the kettle. I'll have to keep George away from that. It might be a bit hot for him. So I'm filling up the cup there, and that's nice and full now. And then I'll just top it up a bit more. What I'm going to do is take the ice lolly and place it in there. Okay, George, you've got to stay back for this bit. Okay, so here's the ice lolly, and I've told George out of the way. That's going to go into the cup, so it's in the hot water. And what we observe now is fairly predictable, right? So the ice lolly, the orange ice lolly, is going to melt in the hot water. Obviously the surrounding hot water is going to cool in the meantime, and eventually we'll be left with a cup of orangey water that's fairly tepid. So this is a case of an entropy increasing process. What does that mean? Well, entropy is a measure of disorder, or if you like, chaos. So what's happening is that we start off with a fairly ordered state, where we have the cold stuff concentrated in one area, one part of the cup, that's the lolly, and the hot stuff obviously surrounding that. And also the hot stuff happens to be just straight water, whereas the cold stuff happens to be orange juice. And what's happened is that gradually disorder has increased. So we've now, at the end of the time, got a disorderly state in which the hot stuff and cold stuff are no longer clearly separated. So the high energy particles associated with the water and the low energy particles associated with the ice lolly are now intermingled. And also, of course, there's no longer this sharp distinction between the plain water and the orange juice. So not only is there now greater disorder in terms of what's hot and what's cold, there's greater disorder in terms of what's straight water and what's orange juice. Now, obviously this is a sort of process that we're used to observing in the forwards direction of time, and we would not expect the reverse to happen. We would not expect to observe a tepid glass of half water, half orange like this, and expect for an ice solid to spontaneously form out of it while the surrounding water becomes hotter. So in other words, we don't expect to observe entropy decreasing processes. So now, of course, if we watch the video in reverse, that's what we'll observe, and that will look weird.